Hello everyone, welcome to my YouTube channel. So today we will be looking into designing and developing from scratch a real-time data streaming pipeline. And the technologies that we will be using are a Python script to produce messages to Kafka, Kafka as a broker to produce and consume any messages to a particular topic. We would be using Flink to consume our messages from Kafka, and Flink is basically kind of a new technology that is replacing Spark. We can use Flink's functionalities to aggregate data, and then once the aggregation is complete, we would be then syncing our data into the Postgres DB, and we can view our data, maybe connecting a UI tool, or maybe querying the table itself to see our data is present or not. Now, for this example, I'm planning to use a weather aggregator application. So I would be coding a Python script which would generate every second some random float value for a particular city. So it would then produce a message to Kafka, and then the Flink will be consuming that message. Now, what Flink will do is, based on a concept of tumbling window, it for every city it would do an average for, let's say, next 1 minute of data. So what would happen is, I will be sending messages every second, but what Flink will do is, it will use city name as the key, and it will keep on collecting the values uh, of the temperatures for each city till, like, let's say 1 minute, if I say, and 1 minute has 60 seconds. So I will keep on collecting values for 60 seconds, and then I would just need to store the average, because I just care about the average weather that has taken place over the past minute. I don't care about the temperature changes every second. It's not like a stock market, right? So I would be adding that logic of aggregation in Flink, and Flink has libraries to take care of it. And then once that aggregation is complete, I would then push it to the Postgres. Correct. So yeah, now how the tumbling window works in Flink, I would like to keep that concept for a next video. In this video, I'm assuming that we understand how some of the concepts work. I will try to briefly go over it when I'm doing the coding part. So let's get on with it. So what I would do is, I would first create a directory called, um, let's say, data streaming. Okay, now this is created. Let's go into it. Data streaming. Now I'm also using Notion just to track that we will mark all the tasks that we complete as we go along. So this one is done. Now I need three folders. So what I'm doing is, this Kafka broker will be running itself as a Docker container, and I will be fetching its Docker image directly from Docker Hub. But for the Flink, for my Python producer, this will be the consumer, and the DB. These all containers will be created by me by the local code changes that I'll be creating. So that's why I have three folders for it. So let me go ahead and create those directories as well. So it should be, actually, we can name it as uh, Kafka producer, and then another directory will be Postgres, and then another directory will be Flink processor. Okay, so now we have all the three directories created. Let me quickly uh, fetch my code in my Visual Studio. So open folder, data streaming is open. Okay, just a sec, guys. Sorry. Okay, so I will quickly fetch this here, the code. Okay, so now I see all the three directories are present. Now there is one more thing that I would be needing, and which we would take care of later also. So let me create the file for now. We would be using Docker containers to run our pro- processes, right? Like the Flink consumer, the Python producer, and the Postgres. So I would be creating a file called Docker Compose YML file. This file will basically contain all the service details. I will be adding it later. Now let's start with our Flink. Actually, Postgres should be easy. Like, let's start with our Postgres. Now the Postgres will contain only few things. It will contain a SQL. So what we need is that before Flink writes data to our Postgres, we want the table to be ready, right? So I would need a SQL file, and I'm calling it create table dot SQL. So okay, sorry, I should do it like create table dot SQL. So this will create a SQL file. Now, what the SQL file will contain is my table. So it should be, the query should be straightforward. It should be, let me use caps, create table weather, and then I'm using ID, which is going to be our primary key. Okay, and then I have city, and this is going to be a varchar, and I'm using 255 not null, and then I'm storing temperature, which is going to be average temperature, um, and it's going to be double. Okay, and then our query is done. So now we want this query to run, right? And the way it works is, sorry, Docker containers require a Docker file, right? So I would be creating a Docker file, and that Docker file will basically contain uh, my image. So I would basically name it as Postgres latest, and this will fetch the Postgres image from Docker Hub. And once that image is pulled in, I would then give it a command that copy create table dot SQL file onto my Docker entry point, uh, init uh, db.d. So what it does is, because we are pulling, let me just, because we are pulling the Postgres image using this line, it will let the Docker know that, take this file which is present inside my folder and put it inside this directory, and whatever is present inside this directory will get run when the container comes up, right? And we want that. So this is what it does. Now our Postgres is ready technically, that whenever our container comes up, it runs this file, Docker file, and then it um, runs the create table SQL. So our table is created and present before we start inserting our queries onto it. So let's close all of this. Now let's come to the Kafka producer. Now in Kafka producer also, it's going to be very straightforward. I need a Docker file. I need a producer py, so it should be python producer.py. This file will run in for infinite time, like whenever, as soon as the container comes up, we would run this file, and this file will have some a condition like while one, and it will keep on running for infinite time till the time container is running. We would also need requirements.txt for any Python um, container, or to run any Python file. We would be creating a virtual environment inside our container, and we would let it know that, just run pip install whatever is present inside this requirements file, right? um Also, what I like to do is, because I would be producing my messages to Kafka, I like to write a shell script that before the Kafka container comes up, like the broker comes up, don't start writing the messages to the topic. Because think about a scenario that you bring up the Python, the Kafka producer container, but the Kafka broker is not yet up. So when you start producing the messages, most of them will be lost because the Kafka broker is not up. You will see an exception, and there is a high chance that container short circuits and doesn't run. So what I like to do is I write a script which is wait for it script, and I will go over it what the script will do. So let's first go ahead and copy paste all that is in the script. Now this is a very generic script, so I won't go over it. There's a lot of thing happening, but the main thing that is happening here is it just checks to the port number that the Kafka broker is up or not, and if it's up, then only run my Python producer container. So that's all it is. I will be pushing all of this code to GitHub, so don't worry, it will be available. Now coming to the actually requirements.txt, so I would be needing four dependency. One is Kafka Python dependency, schedule, because I'll be writing schedule. AIO Kafka is a wrapper library uh, to connect with it, and Faker is a kind of a library which does provide us with some fake data, because we are currently not, if you see the slides, we are currently not working with any real data. We are just creating dummy data, so I'm planning to use Faker for that purpose. Okay. Now just to make sure that it runs fine for you and my environment, when I was testing it out, I had these dependency numbers installed, so I would like to keep using that one so that the consistency is maintained and nothing breaks in. But I'm sure it will work with all the latest versions as well. Now coming to the Python producer file, this is going to be very straightforward. Let's start coding it. um, Now there are two three things I will be doing here. One is the connection. I would need to make connection with to my Kafka, and also the topic. So in my case, let's assume that I have a topic, weather, and my Kafka nodes will be running on 9092, and I will be naming it. So I will create a variable called Kafka nodes, and that will be equal to Kafka 9092. This is going to be a string, and then my topic will be equal to weather. Okay. Now what I need is I will create a method. Oh, sorry. I will create a method which is generate data, and then I'm creating a faker object for faker. I need to import it. Oops, I will keep some space for importing here, so I will be importing from faker import faker. Okay, so now I'm going to produce the instance. So before that, um, I would need a a Kafka producer. So my producer will be basically, let me import Kafka producer as well, from Kafka import Kafka producer. Okay, so my producer will basically be Kafka producer, and then this is going to be bootstrap servers values serializer is going to be. So now we need this serializer because otherwise it will send a byte stream. So yeah, so we would be encoding it into UTF-8, and then while we are receiving, like consuming, we again would decode it to the serializer. Um, so yeah, so that's, so in a way the consistency is maintained. Okay, now I create a data dictionary, which is going to be my city, and I'll be using a faker.city, so it will give me random cities. And then temperature for that city would be, I would just randomize random dot uniform, and the temperatures can be between 10-degree Fahrenheit to 110-degree, right? And then I would be importing the random library. And let's import all the libraries that I would be needing here. Random, random dot uniform. Okay, and then import schedule. Yeah, I think these all are needed. Um, One would be yeah, I guess it looks good. Uh, I would also need the dumps one, right? Because I'm dumping it. So I would need from JSON import dumps. Okay, I think that's all. And do I need? Yeah, okay. So I guess this is it. And then I would need to send this data to producer, which will be topic. Oh, sorry, my topic and value will be equal to my data, and we need to flush our producer so that next time it just sends the new data and doesn't interfere with the old data. I will be creating the main file. I'll be calling generate data, and then I will be scheduling it uh, that run every, let's say, 10 seconds. 10 seconds or to generate data. And then while true, I will run my schedule dot run pending, and then I would also let it sleep for some time, just like maybe zero point 0.5 seconds. Okay, let me see if I have everything here. Mm, I think it looks good to me. So my Python producer is done. Now I would create a doc. I would update the Docker file. I've already created it. So I would fetch an image, a Python, and basically a Linux image, which has Python installed, and I would just do copy requirements.txt. So copy the requirements.txt from where I'm running my Docker file onto the base directory, and then run um, set. Uh, Let me copy this. So this is basically running that requirements.txt file so that it knows, um, yeah, it installs all the dependencies. Now after this, I copy all the resources, which is my working directory is going to be slash, and then I copy the weight for its sh file, um, and I'll be running this after adding my Python producer.py file. Again, similar syntax. Now once my Python producer is added, I would be running my Python producer, but before that I would run and wait for my zookeeper and Kafka to come up. So here is the syntax for it. What it does is it it's a command line. CMD is a command line acronym, so it runs, wait for it for maybe 30 seconds, and what it does is it passes the zookeeper server value and the Kafka server value, and once both of these return true, that means they are up, then I give the command to run the Python producer. Now where does these values come from? These values come from the ones that I mentioned in the Docker Compose, and I will come to that point when I am finishing my Docker Compose file. uh, so yeah, this is it. What we can do is, let's try to see if my data is getting created, so and everything is running fine. So the way I do is, right now I am inside my Kafka producer. Okay, so I would build the image, and the way I do is docker build dash t, and I do Kafka producer dot. Let me actually run my Docker first, because the Docker is not running yet. Okay, so yeah, as we can see here, uh, Docker is running now. Okay, cool. So when I run this command, let me actually delete all of these ones. Okay. Okay, so now when I run this command, it will basically run a bunch of commands mentioned in a Docker file, and it will create a image with this name. So let's run this. It will take some time. So it is running. Okay, I think it did run. Uh, so let me check Docker image. If I do Docker image ls, you can see this image is created, and if we also pull in my this, we see the image is running now. To test whether we haven't made any mistakes, and it is actually, it won't work right now, because my Docker file has this condition, uh, that you have to wait. Where is it? Yeah, this one. You have to wait for Zookeeper and all to come up. So let's do that. That we complete our Docker Compose first, and this is going to be version 3.9, and then I would create a networks. Let me copy paste the services part, which is going to be my Zookeeper and everything. Mm. Okay, so here if you see, I have created two services, which is Zookeeper, and it is fetching again from Docker Hub the image and setting it up, and this is my Kafka. Now, obviously, I would be needing. Uh, uh, I would also like to add volumes, but volumes won't be taking anything here. Now, I would be creating a service, which is going to be my Kafka producer, right? So Kafka producer, something like this. It will look like Kafka producer. And if you remember, when we had built the image already, so the image name was Kafka producer. So it will basically, when I run the Docker Compose, it will basically look for this image name locally first before going to the Docker Hub, and it is going to find this image because we have created it. So it will work, and it depends on, we are adding this depends on, so that we let the Docker container know that it depends on the Kafka service. Now, environment variables. Now here I will be passing my Kafka server value, which is going to be Kafka 9092, and this is the variable using dollar I will be accessing here. you know so this is how Docker Compose passes the value onto my other containers. uh, so for this container, these are going to be my environment variables. Similarly, I have Zookeeper server, which is going to be Zookeeper 32181. So where is this value coming from? This is coming from this port here, 32181. And for the Kafka, we have the port 9092. Kafka by default runs on 9092. So this is what we are saying. And we can also pass in the producer interval, although we are not using it right now. And they have to be on the same networks, so that the containers can talk to each other. When I am producing my message to this Kafka server, the networks should be same. um, so this is going Now I think we have everything. So if I go back and if I go actually one step behind where my Docker compose is, and if I do Docker compose up dash t, it will basically pull Kafka, it will basically pull Zookeeper, and it will basically uh, run them. After running them, you see till now my Kafka producer any container initialization hasn't started. That's because I have added the depends on code. Now once this is done, okay, so let's see Docker ps dash, let's see our container, and it seems that our Kafka producer exited. So let's see the logs here. Docker logs dash dash tail 2000, and I would get the id of it to see where it went, and it said the permission is denied. Okay, that could happen, and there is a way to go about it. Um, Wait for it. Sh bin slash permission denied. Let me see my Docker file. Um, hmm. Mm, Maybe the permission is denied from my side. Mm, okay, I'm back. So the way I fixed it was changing the permission using chmod. And right now, if you see the logs, and we can see the cities with the data is being produced, right? So we see a city. I don't know if this city exists or not and where it is, but we are seeing some city name and the temperature of it, right? So that means it's working. So let's bring down our containers right for now. And yeah, now focus on, because I don't want it to keep on generating till the time we code other stuff. So I think our producer is working as it should. Now the only part left is our Flink processor. So for Flink processor, I would be actually using a similar method, which is wait for it, and then I would just paste it here. Okay, because Flink processor is consuming from Kafka, so I want it to wait for the zookeeper and Kafka to come up. Now moving on, because it's a Flink. Now Flink is currently supported in three languages. One is Scala, Java, and Python. I am using Java because it's a good way of learning how we can achieve Java, using Java, how we can achieve our data aggregation. I remember Spark is uses Scala mostly, but I'm sure Scala is JDK based, so we can code Spark in Java as well. Anyways, let's get into our Flink processor. Now I would be needing a Docker file. I would be needing a POM. We'll be using Maven for dependencies, so I'd be needing a POM file, and I would be also needing a source directory, right, for our classes. Now for the POM one, I'm just copying and pasting all the dependencies that I had, because adding it one by one would take a lot of time. As I said, I'll be pushing all of these to my GitHub, so you should be able to access it. Don't forget to change this group ID to whatever name you will be using. I'm using Flink version 1.16, and so based on that, what I'll be needing is, I will be needing one of the major part is the Postgres dependency, because I'll be connecting with Postgres to sync the data into the Postgres table. Um, and we are also using logging, but yeah, mainly another part is where is the streaming part gone? Connect table API streaming. Yeah, this is the one. This is the main dependency. Flink streaming Java. This dependency will let us consume the messages from the stream of Kafka and then do aggregation on it. So we need this, and also there will be a dependency to connect with the Kafka. I'm not able to find it right now, but it's there. Okay. Yeah. Moving on. Yeah. Here is it. The Java fake Kafka clients. Yeah, this one. Yeah. So we have all the dependencies ready. Now it's all about coding the logic. So I'll be using uh, also, because I'm using logging in my case, just to show you that how the streaming data is being retrieved and how it's aggregated before syncing it to the databases. So I will be creating, let me go inside the source, and I'll be creating mkdir. Let's create using this only new folder. Oh, sorry. New folder main, and then inside main I would just have a new folder Java. Okay, and for the source, inside source I would also like to create inside main, actually I would like to create resources, and in resources I would basically have something called properties for logging, and I will just paste it here. As I said, I will have all of these in my GitHub, so feel free to use it. Now let's come to the best part of the video, which is coding our logic. So we would be needing three files basically. One would be a weather class, a weather deserializer, because we'll be deserializing our schema which we get from Kafka, and then other main file. So let's create all these files first. Main.java, and then we would have another file as weather.java, and then we would have weather deserialization schema.java. Okay, cool. So we'll start with weather.java, as it's going to be little bit straightforward. I will import, and then it would have two objects. One is city. Now before jumping on, so I will want to show you how the message will look like from the Kafka's perspective. It's going to look something like this: city, and then we would have New York, uh, temperature. Oops. And this will be in string, right? 10.34. So we will be converting it into double. So we'll be getting the message in this format. What I'm doing here is I'm just consuming it and creating a new object of that weather, so that it's easier for us to manipulate when we are calculating the average. Because when calculating the average for, let's say, 5 minutes, we would be collecting many instances of weather for that particular city for the 5 minute period. And then when the 5 minute period is being done, we would be doing average of it, right? So double temperature, I would create a dummy constructor, and then I would be creating another constructor which is going to be string city. We would be overriding method to string. This is basically called when we want to print it. So we will be using a method called string builder. So we will be using that. Um, Final string builder, new string builder, and the prefix will look something like this, that we have weather, and then this should be sp dot append city equal to. Similarly, we would append comma temperature. Okay. I guess this is done. Now we would jump on to our deserializer. So what deserializer will do is it will take in the raw message from Kafka and map it to our weather object, and weather object being the city and the temperature, right? So yes, let's start with that. Let me create my class weather. This object mapper is basically mapping the raw message to my object message. Right. Um, so there is a now because we are uh, you know inheriting from abstract deserialization schema. We have a method which is the open method. So what happens is, um, the best part is that every time we see a raw message, we don't want to create a new object for this object mapper, right? What we can do is that we can have one object of object mapper, and whenever any raw message comes, it just maps to a new object of weather. So basically, one object of object mapper and maps to many of weather objects, right? And then that weather objects can be aggregated in our main.java file. So here I will be using a open method, which is initialization, and we would be importing all of these, right? Otherwise it will fail. So object mapper, json mapper dot builder, new java time module. Now here comes our main method, which is the deserialize method. We would override that public, and we would be returning a weather object. Deserialize, we would consume the byte message from Kafka. We will throw IO exception in the case it doesn't work. Object mapper dot read value message comma weather dot class. Okay. Now let me import all of the dependencies. Um, okay. So think our deserialization part is ready. Now comes a lengthy coding part. So because of time constraint, I am just going to copy paste this thing, so that it's easier for us. So most of the part I'll be copy pasting. So let me grab my dependencies in my main.java, and I would be have using some helper function, and I'll go over it what I'm doing in those helper functions, right? So here inside my main function only, I'll be using okay. So now I should have a main method. Now before that, let me go over it what I'm doing here is. So what I do here is, okay, actually it's better to uh, uh, explain when I have completed the code. So public static void main. So stream execution environment, what it does is it gets me the streaming environment, and this is imported directly from the Flink streaming Java library. And then what I do here is that I create a source. So my source is going to be weather, and what it will say is I will have a Kafka source, and have a weather, and then source will be equal to Kafka source dot weather builder set boot bootstrap servers. Oh, brokers. I would need to create brokers. So my brokers is nothing but going to be the Kafka colon 9092, the way we did it in the Python producer. So it's going to be brokers Kafka 9092. Okay, now I have the brokers. Now after brokers, I have set it up. Now I would set a property, set property partition partition. Now I would set topics. In my case, it's just going to be one topic, which is weather, because we are producing two weather topics, so we need to do that. Set group ID. Now this group ID I have already hard coded in my um, 9292. So in my POM file, so you can use that value. Set starting offsets offsets initializer dot r list. I'm very bad with the spellings. It should be a method. Okay, and then we set the deserializer. So what we are saying here is that create initialize a streaming environment that be ready for streaming. Now you need to stream from the source, which is going to be my brokers. My topic will be weather, and once you consume that, set value only uh, the deserializer, which is going to be new weather deserializer schema. So here I'm assigning that, use this deserializer that I have created and give me a Kafka source, a list of Kafka sources with weather objects in it. Now this is just going to give me weather objects in it, right? Now what I'm trying to do here is I've just set a source. Now I would create a stream which is going to be my data stream source, and this is going to be weather again, and this is going to be Kafka environment dot. Now I'm setting my streaming environment at whatever source object I have created, and streaming environment. Now set this source watermark strategy. Now what is watermark? I will again explain maybe in the next video. Maybe I can quickly explain what watermarks is here. So what happens is, let's say I have a time interval of 1 minute, right? So let's say New York temperature, and everything here is event time. So event time is whenever I consume the message from Kafka, when the message was produced in Kafka, right? So New York, comma 10 degrees. This was produced at 1 minute 1 second. Let's say this was created at 1 second. Similarly, New York 11 was created at, let's say, 5 seconds. Now, let's say New York uh, 12 was produced as 6 seconds. Now, because my time interval is 1 minute, so anything between zero, anything between 0 and 60 is to be consumed and aggregated, right? Because I have a aggregation window of 1 minute. So if my events are produced at time 1 second, 5 seconds, 6 seconds, I should get them and then average it out, right? For the aggregation. The issue here is this message was produced at 6 seconds. But what if I receive this at the 70th second? Now I receive it at the 70th second, but the event timestamp attached to it is still the 6 seconds. So what happens is when my Flink sees that, oh, this event was produced at the 6 second, but I am actually consuming it at the 70th second. So right now my window has passed. So what should I do with it? So this watermark strategy actually tells what I should do with all the messages that don't lie within that time period. So currently I'm doing no watermark. So what will happen is we will drop this message. Like that is a trade-off. So we will be losing out on our accuracy. So but because we are using average as our aggregation, basically our accuracy won't be affected that much, right? If it was we were summing something, or if we were subtracting something, then it might be of essential use, right? So this is what watermarks tells me. Now going here, Kafka. Okay, now I have the source created. Now I will create a stream. So what stream helps us in doing is, whatever I have created previously. Now here I have a stream source of weather object. So what happens is this stream source is getting updated continuously, and you can assume it as an array of weather objects, like maybe 10 or 20 objects are there. Now what I tell it to do is, that whatever is the window, ongoing window, uh, temperature stream. So whatever the window which is going on right now, which is Kafka, so let's do key by. So what key by does is let me my event yeah my and because I have already created the weather object, um, I know I can access the city. So here what I'm doing is, from this stream, group by key. And what is my key? By city. Because I want, let's say I have a stream, and the stream is like New York, comma 10, New York, comma 11, Chicago, comma 20, Chicago, comma 22.34. Like this is the temperatures. So what I want to do is, now this stream is there, but I want to take average of this, right? So in order to take the average, I need to group by them. So this group by is done by key by. So I would just group by them, and then I would just pass in that, hey, group by them, and take the window size of, let's say in my case, I said I will be doing, let's say, 5 minutes. Or 5 minutes could be huge because we want to display the result. So let's do 60 seconds. So every 60 seconds, window them into 60 seconds, and then aggregate them based on my new average aggregator class. Now what this is doing is, let's go into this. So here I'm grouping by the city, and then I'm calling this class average aggregator to do something. Now what this average aggregator is going to do, it what in this particular window, there is going to be 1 minute window. It will create an average aggregator for each uh, new average aggregator object for each city. And for each city, it will do, basically it will update the city name, it will increment the count, and it will just add the temperatures to the ongoing sum. Initially the sum is 0, count is 0. Now why I'm doing this? Because later on, when I need the average, I can just do sum by count, and this is what my average is. So in that 1 minute window, whatever city is there, I just take that city's sum, and then divide it by how many times that city's temperature I saw in my stream of 1 minute. This is what it does. I hope this is clear now. So now once this is done, what I need is, now here I am getting my aggregator is getting, what do you say, uh, three values will be returned, right? Because I am aggregating here. So no, so actually I'm getting my average, my average object and the double object. So what is happening is double is basically the average, and my average is actually returning me the all these three values. So right now I am getting four values, but I don't want four values. I basically need three values, two values, which is city name and this double average. So I can again pass this data stream and give me a tuple of which is going to be string comma double, and then city and value stream, average temperature stream, and then here I'll do map tuple 2. Oops, yeah, this is there. My This is my input, that take this input and return me tuple 2 of string comma double. And how it will do is, I will actually do the computation here itself inside my map. So just go over this map, I'll override this method, public um, tuple, sorry, tuple, and then my average input. So this is my input, throws IO exception, and what I need to return is just return me new tuple which contains uh, my first input. So my first input is f0 dot city, and return me the second input, which is already my average. And this is what I need from you. Now what this will do is, this will actually map over this my average and double uh, input, which is going to be in my average temperature stream, and just return me city name and this, and we can see that is working. City and value stream dot print. So here we would just print this, and we would see whether it's printing it or not, right? Okay, so we need to print it. Right now I'm not doing anything with the Postgres, right? So uh, yeah, this should be good. Okay, so now I go to my Docker Compose, and I need to update my Docker Compose to have the Flink processor also, right? So my image name is going to be, I'll just copy everything from here. Uh, the name is going to be same because I'll be creating the image using Docker build, which is going to be Flink processor. It depends on this. Zookeeper server, yeah. And the topic is I'm hard coding it. Okay, so let's try and see if it works. So let me create few more terminals. Okay, so here, okay, so here, source main. Oh, I by mistake created this. Okay, and my Docker file is, oh yeah, Docker file is left. Sorry. I also need to update Docker file, so I'll quickly copy paste this and I'll show you what I'm doing here. So here again, same as Python, I am fetching a Linux container with JDK installed, and basically this command runs all the required dependencies. Now again I copy paste, wait for it sh file, And here I'm creating the jar file. This jar file will basically create a target folder, and then this target folder will contain this jar, because it's a jar basically is an executable. So what it does is, because we are coding in Java, it creates an executable file and then pushes that executable file to the container, so that we can directly run that executable, and that executable takes care of fetching, consuming messages from Kafka and aggregating them. So let's see where I am. I am inside. I need to go one more back. Okay. So here I will do Docker build dash t uh, Flink processor dot. So if it works fine, we should see a target folder created, and everything and an image should be created. So I think we got an error. Um, Calculate checksum of this target file not found. Okay. Uh, oh, I think I needed to create a target file before actually running it. Uh, yeah, my bad. It should be. I should need to run Maven clean package. I have Maven installed. Yeah, this is another thing. So what this will do is, it will run this, and if okay, so we got an error which is like main Java line 53. Oh, sorry. This is an issue. So here I will go ahead and I will run this command again. So here, if everything works fine, no, it didn't work fine. Weather.java. I have a bunch of errors here, which is this. Is it all related to? I think it's related to weather. Yeah, I do make a lot of these silly mistakes. Okay, we got another error which is going to be main.java cannot find symbol city, line 40. Okay, line 40. Why is it throwing an error? Let me see. It could be because of something else as well. Yeah, weather.java is having an issue. Line 31, 18. Oops, sorry. My bad. This is because of my mistake. Okay, I had city in caps. Okay, so I think we are close. Uh, IO exception. It's giving me an issue on for the line. Actually, this one. Let's make it exception. Okay, so I think it's working fine now. So once this is complete, yeah, it's complete. Build is success. So we see a target, and we do see a jar file. So we are interested in this file, which is with dependencies. So in my Docker file, if you see, I have this file copied as this executable. So now let me check my images. There should be producer image only. Okay, so now I can run the previous command of Docker, this one. So right now it should be able to find my jar file, and I think it worked. Docker image ls. Okay, so now what we can do is, we already have producer working. We can actually add our Flink processor to my Docker, and then we can just view the logs to see if it everything is working fine or not. Right. So for that, I will go to my Docker Compose and let me quickly check. Everything looks fine. Yeah. So we can run this now. If we run this, um, let's me see if there are no containers. Okay. So now if I run this Docker Compose, actually I need to go. I'll use this as my parent one. Yeah, Docker Compose is here. Docker Compose up dash t. Oops, sorry, up dash t. So this should bring up my Flink processor also. Let's see the stats. Uh, let's see the logs actually. Docker logs dash dash tail 3000, and Flink processor container is this. Okay, so is available. Right now we need to wait for 1 minute. In the meantime, let me see whether logs are being produced from my producer end. Oh, the Flink processor exited. Okay, so it is giving me no error. 19 seconds. Yeah, it exited. Uh, hmm. We are not seeing any errors as such in my Flink container. So, what could be the reason it exited? Um, hmm. Let's do this. Uh, Let me bring down everything, and let's add some logs here. Oh, along with that, I also need to make sure my yeah, let's do this. Okay, just making sure that things work. So environment created. I'm adding logs after each step, just in case if it just to be sure that it doesn't break. Yeah, so environment created. Okay, now I like to remove all the volumes. So I will be building image Kafka producer. I will be building image for Kafka producer, and I will be building image for, oh no, first I will do Maven clean package, so that the new tar file that is created has all the system.out.println functionality, right? So this image is created. Okay, now I can create this image docker build Flink processor. Okay, so images are created. Docker image ls. Okay, so docker compose d. Let's hope that we do see some logs which are causing the issue. So docker ps dash a. Okay, so it did exited. That's fine. Aggregation is created. Hmm. Mm. Oh, I think I got the issue. So it should be, I need to execute my environment, the streaming environment that I created. My bad. So it should be Kafka Flink Postgres. Yeah, I need to just execute this. Yeah, my bad. I think I this is the issue. There is no error as such. Mm, Once the containers stop, I will actually delete everything and create everything. Yeah. So just create, delete everything, images as well. Okay, so here I would do this. Here I would do the Maven clean package. Okay, so now the image package is created. I will create the Docker image. Hiccups are part of software engineering, I guess. Okay, so once the image is created, okay, let's do this now. Fingers crossed. I hope it works. Oops, this time. I know this video is getting very long, but I assure you it's going to be very quick. After this, only one thing which is left is just adding the Postgres sync. So we have, what do we have here? Let's see. Okay, I think it worked now. So Docker logs. Okay, so we have the thing running. Let's wait for 1 minute. Actually, I should run the log here. We should see the Kafka producer log here. Docker base dash a docker logs. Uh, so we have producer. Okay, so it has produced some messages. Let's view uh, how it's the case in the aggregation part. So we would only see logs after 1 minute because we have the window of, okay, we do see it here. Okay, so port Jennifer 106. Okay, yeah. So right now, if we do see more values from port Jennifer, then the average will change. Right now, it's just, it's all unique cities. So that means we should see. It will take 1 minute, to display the new cities. um, and after 1 minute, yeah, now we should see more cities. Yeah, we can see that. We do see more cities here. Okay, cool. So I guess this is working fine. Now what we can do is we just need to add the database, and we just need to sync it to our database, right? So what we can do here is, we already have the stream. um, so we already have this printing part, so I will remove this printing part and just add a sync. So there is a method called add sync, and we have jdbc. This is the dependency that we added. Now we would need to run a query insert into weather, uh, and we need to insert um, id. No, id will actually get inserted automatically. City, and what was it? um, Average temperature. Yes, this is the one. City, comma, average temperature, and then we have values, and then there will be two question marks. This is the syntax that we follow. And then we'll have comma, jdbc sync. Let's get this down one level. Okay, so we have the statement, comma, event, and event is basically having two values, right? So uh, we would set string. The first part is going to be event dot city, and the next part, set string to, actually it should be event dot f1 and event dot f0. Yeah, something like this. Okay, and then I have I will copy paste the. So I'm when I create a Postgres DB, I am going to add all these settings about the username, password, and all. Obviously, it's not a secured format to just pass this hard coded values here. I am passing it because just to make things easier from the development perspective, we need it. But we should never do that in case of production. But yeah, unless it's an internal service. So yeah, here if you see, I have the context as dot slash postgres. What it will do is it will go inside this folder, and it will try to find a docker file there, and it will run and create an image there, right? So this is what it's doing. And then we have environment as postgres user, postgres password db. So this is all done. What we can do is, I'll quickly come here and see. Okay, we have got a lot of values aggregated in the Flink producer, and this is also. Let's stop everything. Let's go to our main, this thing. I think everything looks right. Uh, yeah, all the containers have stopped. Now, as I told you, I would like to delete them. And create the images for them. So producer image for this one, I would again need to do the Maven clean package because I recently created. Okay, I got an error which is like line 61. Line 61. Okay, why is this erroring out? Statement. I think it's the statement is taken like this. Okay, it takes a new line. Okay, so we got another error which is double cannot be converted into string. Oh, so this should be said double. Yeah, my bad. So okay, so now it should um, create the jar file successfully. Now my jar file is created. I will actually create the image. It will take some time. Let's check how many images. Oh, we it is fast. Okay, so we have created our images. Now for the doc Postgres one, it will create it on the fly because I have given the path. To be honest, instead of doing the build command, I could have also done the same thing in the Docker Compose for this one also. Like if I have done this, it would automatically go into this folder, find a Docker file, and create an image for me, and then create a container based on that. But I personally like to test it out because those are the proper implementation. Let's run it and see if it works. Okay. So if the sync thing works, in that case, I guess we should not see any error in terms of Flink. So Docker PSA. I think let's check our logs here. Docker logs. So producer. Okay, producer is producing the messages. Let's check our Flink job. Okay, I think 1 minute hasn't passed yet, so it's still taking time. Oh yeah, we won't be printing anything. Actually, we will be directly adding it. So let me actually get into my Postgres container and see if it works. Till now, let me check. We haven't seen any errors, so I think the data is getting inserted in Postgres. So the way we can check is we would get into the container and run the Postgres. So this is the way it works. So my container name is Postgres, and then I will run the command psql, and then the user is obviously Postgres, and the password is Postgres. Yeah, and then now I'm inside Postgres. Let me see the we see we see a one row is added to it, right? And we do see um, a weather table. So let's do select star from weather. Oops. Oh, awesome. We do see 10 rows by now. So we do see the city and average temperature getting added to my table. So I guess I know this has been lengthy video, but I guess everyone is clear now how we can create a pipeline using let me quickly pull up this chart using Python, Kafka, Flink, and Postgres. If you guys like this video, please subscribe to my channel and give me a thumbs up. It does help me a lot. Thanks, everyone.